I was invited today to present the CBTN research resources, which you've heard a lot about already, as well as the data access requests. And before I do that, I was going to introduce myself, but Brian did such a great job of doing that I'll save a slide. So my objectives for today's presentation is to really show CBTN's impact on the research community, the genomic data available, and how to access, an introduction to the CBTN support team, and a brief discussion on where we are headed. So what is the impact on the CBTN and on the pediatric research community? So our first bit of impact starts with the Pediatric Brain Tumor Atlas, which we've heard a lot about today. I think Mathieusz put a nice introduction to that effort as it being the second largest cohort for our biospecimens. But it was made available to the research community in 2018. And this cohort includes sequencing from 2,000 specimens from 1,000 clinical events with 58 distinct brain tumor histologies from 943 patients. The PBTA includes matched tumor normal, whole genome sequencing, tumor RNA sequencing, methylation, and proteomics, as well as the longitudinal clinical data from over 4,600 subjects within the CBTN, images that Ariana highlighted earlier today, and the radiology, pathology, and op reports. So with this PBTA data set available, CBTN has supported over 195 data science projects, which you can find on our website, or you can attend tomorrow for the summit and the poster session, which I'm sure we'll hear a lot about those projects then. CBTN averages 34 data requests per year since 2017, with a total of 203 submissions. So CBTN's goal is to have this data set integrated with others, as well as generate additional foundational data and communicate this through the network to increase the usage of the PBTA. And Deanne just showed us some of that integration just prior to. The PBTA data is available to anyone around the world, and more than half of our requests come from non-CBTN researchers. We've also received requests from US and non-US institutions, including Canada, Europe, Australia, China, and the Middle East. And CBTN will continue to partner with as many institutions and countries that share our common goal in finding cures for these diseases. Because the CBTN biorepository collects and generates data from many different tumor types, we've been able to support many different histologies of interest, with 30% of our data requests for DIPG, DMG, and high-grade projects. And our goal here is to really accelerate discoveries for all pediatric brain tumors. And this graph isn't representative of the amount or types of data that is available to the community. CBTN has been referenced in more than 100 scientific publications and 25 scientific abstracts. So what are the available CBTN research resources? And we've highlighted this a lot. Brian highlighted this earlier. And he also mentioned that the PBTA is currently undergoing a second cohort of sequencing, and this PBTA cohort will represent the largest amount of its kind, and it's the first time this much pediatric brain tumor data will be available to researchers. Currently being run through our harmonization pipeline, so a little shout to our bioinformatics team. This cohort represents close to 2,000 subjects and 500 trios. So just to talk briefly about the PBTA data size, the PBTA will generate almost a petabyte of data between the two cohorts, so the existing one and the one undergoing data now, generation now. But what does this mean, and how can we begin to wrap our head around what a petabyte of data even looks like? So thanks to Adam, I don't know where he is, he helped me with this slide to pull in some real world examples for us to even imagine this. So this first graph says a petabyte is 11,000 4K movies, which will take you over 2.5 years of nonstop binge watching to get through a petabyte worth of movies. So imagine that. And then 4,000 digital photos every day for the rest of your life. So that's, you can just imagine that at all. That would be what an equivalent of a petabyte of data would be. And part of why we have so much is because CBTN's goal is to generate what we call this foundational layer of data. So researchers are able to have the full picture of a patient's genome. When we look across the existing PBTA data set, not including the current EXO-1 cohort, there are close to 2,000 subjects with tumor and non-tumor whole genome, followed by 1,400 RNA-seq, 900 with methylation, and 200 with proteomics, and close to 100 with single-cell data. With our current EXO-1 and methylation efforts, along with the recently awarded proteomics EXO-1 efforts, we're expecting these data types to double. And this slide here, we're trying to look at the data modalities across histologies. And note that this slide is not representative of the amount of histologies available, but we can see in this slide here that low-grade gliomas has the most data available across data modalities, with close to 1,200 subjects having at least one data type available. And in this graph, it might be hard to see, but there's ATRTs, DIPG, high grades, cranios, ependymomas, and medulloblastomas. So how can an interested researcher access this data? Much of the CBTN PBTA data files are protected under this three-tiered system. Some files are open access, which means anyone can come to the website and explore some of our metrics. The CBTN minimal clinical data, imaging data, and the process genomic data are protected within this registered access tier, which means data is available to the public as long as you register to that portal. And lastly, this raw genomic data is considered control access and therefore require permissions from the CBTN Data Access Committee and an executed data use agreement before the data becomes available to non-CBTN institutions. But coming soon, however, users interested in accessing the CBTN PBTA data will be able to request access through the NIH dbGaP. Access through dbGaP will require users to have an ERA Commons account. And with NIH managing the governance, access will be accelerated for users as long as they agree to the NIH DACS terms and conditions, which includes a data user committing to not re-identifying any research subjects, will not do anything with the data that the patients did not approve of in the signed research consent, and end users committing to appropriate data handling. And with this integration or with data access being transitioned to dbGaP, we will also remove the need for this institutional signatory, this back and forth that we see to execute the data use agreements for these non-CBTN member institutions. And then once your data access request has been approved, users will be able to access the available raw data files through the Kids First Data Resource Portal to download. Or if you don't want to download them, you can go to the portal and build your cohort of interest. And once it's approved, you can push your data files to a Kavatica workspace where we seen earlier, where you're able to just upload your data and integrate it with the existing PBTA and have compute and analysis and invite others to your workspace for this shared analysis. Also, the Kids First, the PT-Bio portal is our data visualization tool where you have your process data files, where you can see identify your variants of interest, compare patients' outcomes, and investigate intersections of genomic data. And then lastly, Deanne just mentioned the molecular targets platform. So I'll skip that one. But until all of our data is migrated into dbGaP, Researchers can always request access to the CBTN PBTA by completing and submitting the CBTN data access request form. And Ariana highlighted this earlier for any of the imaging requests as well. So just to introduce you to our CBTN support team, some of you had already had the opportunity to meet Dr. Higgins, who leads the support team and works with researchers to understand their needs and pointing them to the best portals for their particular interests. But as a whole, the CBTN support team made up of Dr. David Higgins, Arya Kamna, who many of you have worked with already for your requests, Nathan Young, and Dan Miller are all available to the research community to answer questions on data access and usage of the various CBTN data portals that I just highlighted. And this includes monthly offers hours that take place on the fourth Tuesday of each month, as well as one-on-one demos should anyone be interested in that. And if you have any questions, are interested in office hours, this is how you can contact the support team and they'll triage your questions. Before I wrap up, I'd like to take a moment to brief you on what's next for CBTN. With the PBTA data, we will be expanding the release in real time of the Tier 2 and Tier 3 analyzed results that Deanne was just highlighting. We will also release and integrate imaging and histology data on Flywheel that Adam mentioned earlier. Increase the support for precision medicine tumor board process, and I mentioned briefly by generating and integrating that proteomic data for 400 samples, and upgrade the data and specimen request for workflows with biospecimen views within KISS portal. And as always, the addition of data modalities and support for disease-specific expansion. There are just so many people that I want to take a moment to acknowledge and thanks. A big thanks to Arya, Kamna Arya, for being the point person for all your CBTN data requests and providing updates to researchers and really advocating on behalf of all of your projects day in and day out. And thank you to all of the teams and the sites for making all of this data possible for the research community. So thank you guys.